Welcome back, morons! Fluids! Like the sweat bursting out from your pores while you're studying physics. The smoke coming out of your brain is also a fluid. In physics, both liquids and gases are fluids, but for now we only talk about liquids. And for you morons, you can't talk about liquids if you don't talk about pressure. And what is pressure? Well, take a force acting on a surface. Take the ratio between the modulus of the force perpendicular to the surface, and you get the pressure acting on that surface.
But Uncle Isaac, what is that upside down T under the F?
That T stands for turn your mouth off, you moron! Pressure is calculated only with the component of the force perpendicular to the surface, and that's important. If the force is not perpendicular, you must first find the perpendicular component, and then you can calculate pressure. Pressure, by the way, is one of the quantities with more units of measurement in all physics. It's like your classmate who comes to class every day with a different pair of shoes, while you're still using your 2015 Adidas. There's like 12 of them, but let's just talk about the 4 ones you are going to find. First, the most important, the Pascal. Hello there. Hi man, tell them something more please. A Pascal, which, c'est moi, is Newton over squared meter. It's the unit of measurement of the international system. So if you happen to use pressure in equations, you must do the calculations with Pascal's. The second unit of measurement is the atmosphere.
But the atmosphere, just like the atmosphere?
Yes, moron. The contraction for atmosphere is ATM. It's a unit of measurement based on the air pressure. At the ground level, air pressure is more or less 101,325 pascals. This value corresponds to 1 atmosphere. A pressure of 2 atmospheres corresponds to twice this number, so 202,650 pascals, and so on. And then comes the bar. This one is not so used anymore, but if you ask my grandpapa, he will probably tell you that when he was young, he could jump ditches on the long side, and he used to measure pressure with bars. 1 bar is 100,000, that is 10 to the power of 5 pascals. And finally, we have the crazier one, the millimeter of mercury. But aren't we talking about pressure? What's up with millimeters and mercury? Oh, this is a wonderful story about my friend Torricelli. Yo! But it deserves his own time. Just remember that 760 millimeters of mercury correspond to 1 atmosphere. Oh, and sometimes a millimeter of mercury is also called a torr, just to confuse you a little bit more.
But why all this mess for pressure? Who gives a
I mean, can't we just use forces and that's it? Well, let me tell you a little story. Last night I was at my cousin's birthday party, and while I was going wild on dancing, my nephew Rocco decided to land on my foot. Rocco weighs about 120 kilograms. The bruise that he left me had a surface of 50 centimeters squared. So the pressure on my foot is equal to Rocco's weight over the contact surface. That is 235,440 pascals. But the party was just getting started. Shortly after, my Aunt Marie, who is a 60-kilogram walking rake, stepped on my foot with her spike heel. Aunt Marie's heel have a surface of 0.5 centimeters square. This means that the pressure caused by Aunt Marie's weight on my foot was over 11 million pascals. I mean, there must be a reason if Aunt Marie pierced my foot and Rocco didn't. Now you see that pressure must not be confused with force. Sometimes it can help you understand what's going on better than force. And now I see that I'd better go to family parties with the right equipment. If you want to speed up my recovery, subscribe and leave a comment down below. And maybe tip us, link in the description. But you see, morons, pressure in fluids has very strange properties because fluids are very strange people. When you put a fluid inside a container, it fits perfectly into whatever shape it finds. And that's just one piece of the story. The entire surface of the container undergoes the pressure of the fluid, which pushes against the walls. It's like going home after the party and suddenly you have to give a ride to half your family. The inside of the car is packed with humans, and all the surfaces of the car are affected by the pressure of the human fluid inside. Pressure produces a force that pushes outwards. If the pressure then further increases because you forgot to pick up Grandma Elizabeth, the whole car will experience an increase in pressure. This is Pascal's, which, c'est moi, law. When you increase or decrease pressure in a fluid, this variation is transmitted to all the fluid and all the surfaces it touches. In practice, it means that if you blow up a balloon, the pressure on the balloon is going to increase evenly over the surface of the balloon. Come on, dude, a less trivial example? Do you want an example? The water elevator or the hydraulic press. 2 platforms, an underground pipe and a lot of water. So it's just a plugged pipe? That's what your mom said. What? If you put an object on one of the 2 platforms of the press, you create pressure that travels through the water. This same pressure shows up under the other platform, so it rises. And the best thing is that while the pressure is the same, the forces on the 2 platforms are different. Actually, if you use the pressure equation, you will find that the ratio between the forces is equal to the ratio between the surfaces. With this trick, you can lift even very heavy objects with almost no effort. For example, I took my car to the mechanic after the party and he used a hydraulic pressure to lift it. That's when we realized that Rocco was still locked in the trunk. Listen, Pastel, this is my lesson. But come on, Isaac, chill out. Your pressure is going to rise. You know, there's a nice pipe where you could stick your pressure up and...
Your pressure is rising? It's probably the fault of Steven's law.
Oh no, it's Steve. I'm out.
Picture yourself on the seaside, taking a huge dive and going a little too deep, and suddenly your ears are going... That's because the deeper you go, the more pressure increases. At the bottom of the deep sea, pressure is ginormous. The water above pushes down with its weight, and the result is that everything that is not used to living down there crumples like a soda can. Pressure at the chosen depth h is equal to the density of the liquid times g, gravity acceleration constant, times the depth plus p0. And you know what P0 is? P0 is the pressure on the surface of the liquid, like air, you know. If above the water there is air, P0 is the atmospheric pressure. If above the water there is a vacuum, P0 is 0. If above the water there is your mom, P0 is... But let's take a trip into the deepest place on Earth, Mariana's Trench in the Pacific Ocean. Its deepest point is 11,000 meters below the sea. Pressure there is the density of seawater, about 1020 kilograms per cubic meter, times 9.81 meters over second squared, times 11,000 meters plus the atmospheric pressure. This is equal to 110 million pascals, 1100 times the pressure in the room you are now listening this video in.
If you find our videos helpful, please consider supporting us with a tip. You can find the links in the description below. And subscribe! A huge thank you to all our supporters. See you in the next lesson. Ciao!